All right, so as we've talked about in class, if you are trying to solve a quadratic equation and you have at least more than one term, so at least, well, I guess for a quadratic, it would be only two that have a variable, you have to set it equal to 0. So the first thing I'm going to do is subtract x over, so we get 10x squared plus x, and then add 4, so minus 42 is equal to 0. Now you have, or will have, different options for solving. We can use factoring, we can use completing the square. Now that you've learned that, you can use quadratic formula. Here it says under lesson 4.5 that we're going to factor. Okay, so that means I need to use my X method. This is a personal preference, okay? You can use guess and check. There's the box method. Find the method that works best for you. This is the one that I'm going to use. So at the X method, A times C goes at the top, so 10 times negative 42. B goes at the bottom. And it's our job to figure out what multiplies to a negative 420 but adds to a positive 1. So for us, that's going to be 21 and negative 20. So since those two numbers add to a positive 1, I'm just going to expand my quadratic, substituting in those two numbers for the middle term. Now you have a polynomial with 4 terms. Factor by grouping. Find the GCF of the first 2 terms, which looks like it's what? Not that. Hang on, let me... Where is my pen? There it is. Okay, sorry guys. Okay, so the GCF, it looks like it's just a 1x. And so even if it's 1, you have to factor it out. That leaves us with 10x squared. Oh my gosh, sorry guys. 10x, because we're pulling out an x, plus 21. And then on the second binomial, we have to pull out the negative 2, which leaves us with 10x plus 21. When you factor by grouping, these two binomials should be exactly the same, so we can factor out the similar binomial, group what's left together. And then there's this zero product property that states if you have two items, terms, binomials being multiplied together, and they equal 0, then one of them must be 0. So we can, at this point, separate them and set them equal to 0. So x is equal to negative 21 over 10. X is equal to 2. Please make sure you write your solution set together as mentioned in class. Write it numerically. Don't write it numerically. I really don't have a preference. And there's your answer. Woohoo! All right, for the second one, again, we have an x squared term and an x, so we need to make sure that we set it equal to 0 before we solve. I use the x method. A times c goes at the top, so we have a negative 40, and that b value drops to the bottom. So what multiplies to negative 40 but adds to negative 18? Different factors of 40, 4 and 10, 8 and 5, 20 and 2. Haha, there it is. So our two numbers are going to be a negative 20 and a positive 2. Again, they have to add to the top, or multiply to the top, and then add to the bottom. So since they add to negative 18, I'm going to substitute negative 20x and positive 2x in for negative 18. We have a polynomial with 4 terms, so we must factor by grouping. The first two terms has 5x as its GCF, and we're left with x minus 4. The last has a 2, so we're left with x minus 4. Again, these two binomials should be the same when you're factoring by grouping. So we can factor out the similar binomial, group what's left together. And then that zero product property says that we can separate each of these binomials equal to 0 and solve. So x is equal to 4 and negative 2/5. Nicely done. All right, last but not least, real life. Woohoo! Now with these, you guys always seem to get stuck. Don't get stuck. We have a ball, okay, and it's modeled by this function. So it already gives us the equation. And the height of the ball is f of x. X is the distance. So if I'm asking you, how far does the ball travel before hitting the ground? Okay, well, here are my x and y axes. The negative a value means that it's going to open down I don't know where it starts, where it ends. I think it starts at the origin. In fact, it looks like it does, but it doesn't matter. We're just sketching so we can see what's going on. So how far does the ball travel before hitting the ground? Well, if this is my start and this is my end, I'm looking for distance. I'm looking for x. So we're looking for the biggest x-intercept that we can find. Our biggest x-intercept. All right, so that means I'm going to have to take the given and set it equal to 0. And set it equal to 0. There we go. Sorry. In order to get rid of my decimals, now you don't have to, but if you want to, you can multiply by 10 or 100. So I'm going to multiply by 100. I get negative 2. Oh, sorry. Not a, yeah, well, we could do that. Okay. Negative 0.2x squared plus 77x is equal to 0. Okay, so that means I move the decimal 2 spaces because I multiply by 100. I'm going to factor out an x. So I get negative 0.2x plus 77 is equal to 0. So, oh my, sorry guys. So in solving, we get that x is 0. Okay, well, that's our origin. And for that second one, go ahead and grab out your calculators because we are dividing by a decimal. So I have a negative 77 divided by a negative 0.2. And we should get that x is 385. So how far does the ball travel before hitting the ground? The ball travels, remember, complete sentences, 385 feet. Don't forget your units of measure. All right, for B, how high does the ball go? Well, that's going to be at our vertex, our maximum. So it's in standard form. Go ahead and find the axis of symmetry with me, please. So x is equal to a negative b all over 2 times a. You're allowed to use your calculator. So I'm going to take 0.77, a negative 0.77, and divide it by a negative 0.004. And we should get 19.25. Okay, but that's not the height. Remember, height is represented by f of x. So we need to plug that in for every x value to find our corresponding y value. Oopsies. I'm just writing zeros because it's the thing to do. Okay, remember, we're plugging in our h that we found for each of the x values. And go ahead and use your calculator. And when you do, you should get, oh gosh, approximately, if we round to the tenths, 284.6 feet. Sorry. So we'll say the maximum height of the ball is 284.6 feet. Good. Now the last question is, what's a reasonable domain and range? Well, we know how far the ball goes. So we're going to say that the domain starts at 0 and it goes all the way to 385 feet. How do we know that? Because we calculated that in A. We calculated the biggest x-intercept. The range, realistically, you can't go negative feet. Okay, we've talked about that numerous times. So we'll say it goes from 0 to 284.6 because we found the maximum height. Sweet. All right, guys. Solving quadratic equations using factoring. What?